Let's look at this problem again. We are going to try to estimate the sign of these derivatives. One is f of x, and the other one is f of xy. So let me make sure that we are going to explain this one really clearly. So what is f of x? That means the change of value, change of f along x. When x is increasing in this direction along x, if the value gets smaller, then the slope is negative, derivative is negative. If the value gets bigger, then we have positive slope. Now x direction, p is over here, so this is x direction. This is x direction. And we look at the value. So you can see here the value is 8, and here the value is 6, and here the value is 4. So the value along this line is decreasing. So what we have over here, fx, partial derivative, is negative. So this is 1. Now, how can we look at the second order derivative? C and E, we can interpret that one, use concavity. But look at D over here. So if we look at D, we are looking at partial derivative of f of x respect to y. So that's the meaning. So if we want to determine the sign, what it means is that we're going to determine the change of this value. So we're going to look at the change of f of x along the direction of y, along the positive direction. Positive direction of y. Okay. So now we know we are looking at the partial derivative near p. So we're going to draw the y direction line over here like that. So this is the y direction. That's the y direction. And then we're going to estimate the value of f of x, estimate the partial derivative of f with respect to x along this line. And how do we do that? We can use the same idea. If the gap in the x direction is bigger, that means the derivative value actually is smaller in size. So if you look at this direction over here, now remember, the derivative over here is negative. So you can say, look at this one over here. If this one is -1, this one is going to be -2. Because the slope is steeper over there. And you can also see that because this gap over here, you can think about this is 8 minus 10 over maybe 1 like that. So it's going to be approximately -2. We call this length over here is 1. But if you look at over here, you have 2 minus 4 over. This gap over here is almost twice as big as that. So that means your x direction, you have to move 2 units to get the same decreasing of the value. So it's 2 minus 4 over here divided by 2, and it's -1. Okay. So because of the negative value over here, what we are seeing is that when y is increasing, f of x value changes from -1 to -2, from -1 to -2. Now, because of this negative sign, so we know that f of x value is decreasing. Its value is decreasing. It's getting smaller because it's -2, even though the absolute value is getting bigger. So what it means is that fx, this derivative over here, will be negative. Okay. So we need to be very careful when the value itself is negative. we cannot just say whether it's going to be steeper or not. We need to look at actual values or estimate the values over there. Okay, so I'll leave the rest of the estimations to you, but on the other hand, this part over here, the estimation, we want to estimate the partial derivative of f with respect to x, but in the direction of y.